That does not mean that they are wrong. They're just telling you they may be already 15 or 20 years old, and so you don't know how appropriate they are really for the current situation or not. So this is really a very sensitive area. And the more you're experienced in LCA, the easier it is to check if the orders of magnitudes are okay. But for a newcomer, it's really difficult, yeah, to handle that. And at least the more you step into this databases on the beginning, I'm honest, you're a little bit confused, yeah, because it's really tremendously what is in there, and at least you have to track back. And if you look, for example, only for one chemical, and you find in the list the same chemical 20 times, yeah, because it can be made from different sources in the database. Could be for Europe, could be for India, could be a specific process. So it's a kind of learning, and this is why this iterative process in LCA is so relevant. You end up with a first result and have to check what is a key contribution, and then go back and see if the key contribution is really appropriate. So as I've mentioned before, there are many different LCA tools that exists. LCA is a methodology, and normally in this tool the methodology is properly included. In many cases, you start an LCA with a pen and a paper. Yeah? Especially when I'm in an industry, in a pulp and paper mill, we still very often see a flow chart of the facility, and then we start really putting the main unit processes on a piece of paper to start to understand the key processes. So there are many tools available. Some of them are open source. Most of them are really for purchase. And also many data sets are available. A few of them are open source. Most of them are for purchase. Our experience is all these tools, they calculate properly, but it really depends on the user. He has to know what he does, which is the same with all computer programs. Yeah? And at least the more sophisticated, these tools sometimes are very sophisticated. That means they have many things in there you don't really need at the moment. Yeah? And that sometimes makes it very difficult to see what do I need for my LCA now and what is meant for any other users. Yeah? And this is really very, very challenging. But that is a reason why I try to recommend at least two tools. They have the big advantage that they are based on Excel. And Excel, I'm sure you all have opened once an Excel file and done a calculation in Excel. And when you do so, one of these models is this GREED model. The GREED model was developed in the US, I would say 25 years ago, and it has globally more than 60,000 users already. So it's really a widespread tool with many, many users. And the good thing on that tool is it's for free. Yeah, so you can download the packages, and you get also there are tutorials to watch and see how the GREED is working. It's very spread in the academic sector. Yeah, so half of the users are really academic. Yeah, so it really has a good functionality, and it has all data you need to run the model are already in the tool. This is all very great. They reflect to a high degree the US North American situation. But anyway, some of their chains are also happening in other countries. For example, battery production or the mining of specific minerals. So at least all these data are really implemented in the GREED model. And the GREED model really is a full LCA, covering on one hand, when we talk about vehicles, the well to pump. So really starting from nature to develop the fuel supply, and also in a vertical way the building of the facilities here on the example of building the vehicles. The model is split in several parts which are directly connected. So at least it's a quite good life cycle analysis model, and they update it year by year. So now you get a brand new version that was published last week. Yeah, so really a good update on data, and how does it work? Just to give you an example, the colleagues from Argonne National Lab, they used to take this process about the flubber production. And flubber is not a real product; it's a fictional product. Just to explain how you do it. So if you want to insert a new process, you make the flubber process, yeah, and you have specific inputs, you have specific emissions, and you put in flubber ore, and the final thing is the flubber, and you have to think about where is the material coming from I need for making the adamantium. Yeah, I also have to insert a new unit process. So it just guides you through how you build up a new process, and then you have the flubber ore. Then you add a process. The black ones are all unit processes where you say I need the ore mining first, and to insert that. Some of the materials are already in the database. If you need a new material, you have to start a new data set. But I think, or I assume that most of the data you might need for one of your first or initial LCA, I'm quite sure you will find all these data in the grid model. In different units, you can also change the different units from liters to kilogram and the heating value and so on. So this works relatively relatively well. And at least what they do, they give you a background data for the baseline technologies. Yeah, so you will find in for transportation, ships, trucks, aeroplanes, if you want. So for the baseline technologies, for power plants, for heating plants, they are all there. Yeah. Secondly, also for field operation, and the farming data, and also extracting oil and ethanol plants. That is at least very well uh, integrated there. And still, you always have to be careful about the data you really use for your calculation. Yeah? And in the beginning, of course, if you have a supervisor helping you with that is quite well, because when you end up with a result, you need a clue if this result is somehow reasonable or is it not. Yeah? But anyway, I should this grid model is I think a very good thing. It includes many different vehicle technologies. So all the vehicles, and if you deal with biofuel transportation fuels, of course, if you also include the vehicle, is very nice, because then you can really compare it to different fuels, especially when you compare a bioethanol vehicle to an electric car. You always have to go on the car level, because per megajoule of ethanol or megajoule of electricity, you cannot make a reasonable comparison how much you emit when you drive 1 kilometer. And they really have many different technology, conventional combustion engines, but also hybrid electric vehicles, fuel cell vehicles, battery powered vehicles, plug-in hybrids. So everything is at least available, and to use this data is a perfect starting point. And even if you don't like this data, you can copy them and insert your own data. If you think, oh no, my vehicle is a little bit heavier or less heavy. So this is really a good thing. The other good thing is that this grid model really covers, I would say, all energy systems from today and even from future. You see here, for example, they have a very big block on renewable energy and fuels. Yeah, they're also covering hydrogen, electricity, but this one is really covering different first generation feedstocks, corn, sorghum, soybeans, and so on, and also second generation feedstocks, and they also have algae systems in there. So for your need, this is very well developed and accessible for the biofuel area, and you find many default values you can use. Yeah, and if you have a different pre-treatment step, you take the existing one and you modify it maybe to your needs. So it's relatively easy to include that. So they really have a big amount of different energy carriers, and that is relevant. And you see that this is a similar picture of making electricity, because electricity can be made from so many sources, and electricity is always a key in LCA. Yeah, it's always a question, where is the electricity coming from? So in that model, you really have the possibility. You have all the different ways of producing electricity, and if you only want coal power plant or only renewables, you can put in your own share where the electricity is coming from. So, for example, you can insert the Indian electricity mix, and you get an emission factor for the average Indian electricity. And this is at least very good. It additionally really has a full LCA, so you get also for all the power plants, you get a list of materials you need to construct a power plant. Yeah, so you really have an idea how much concrete, how much steel is already in there. And then you can also push a button and then you get the results, how much CO2 is emitted when you build this facility. Yeah, so it's really a very, very comfortable tool. And it has also a separate tool which is integrated in the others, specifically dedicated to land use and land use change. So if you want to step into the area of land use and land use change, I really recommend you to have a deep look on this, because it's on one hand explains, and on the other hand it gives you the key factors and many data, and they always refer to the data. Yeah, so from a scientific point of view, it's really well done. So maybe the data are 2 or 3 years old or even older, that does not matter. Still, it's the best available scientifically sounding data set that can be used for analysis like that. And it's also with the land use and the land use change. Recently, in the discussion on these electric vehicles and the battery production, there was a long discussion, how do you really make a battery and where's the raw material coming from? And in the GREED model, they spent much effort. They really visited the ore mines in China or in South America to really see how they're producing the materials, the specific materials, especially the lithium and the cobalt, and yeah, however, and how you really produce a battery. So they have really the most recent data in this area on battery, and also the other data. Um, so you see from my enthusiastic description, at least this is really a very recommendable program, really covering a broad range of different things. And still, you need to know what you do. Yeah. So really, still, you need to know what you do when you handle such a tool. You really have to be careful. Then the good thing is you can use this tool as they're already predefined chains. Yeah, you can start looking on the existing chains, look on the results, and see how they look like. Yeah, and you look on the bioethanol car, and then you go in the different processes and see what is in there. That's a way to get to know and learn on the program, and then you can start in changing a number and see how much it affects the result. And this is at least one way to get to know the program. In the past, at Yoneum, to be honest, we always checking different tools. And as I've mentioned before, none of them is fulfilling all our needs. So at least we're using a mixture of different tools and databases. And sooner or later, we always import or export something from Excel. Yeah? Because this is at least the most common data format where most of us are familiar. So at least sooner or later, we really only can use programs that have an interface to the Excel in both direction. Then at Yoneum, it is reasonable. And you see here the prices. If you pay 3,000 euros per year or even more, I think that's not cheap, even for universities. I don't know what is the price for universities, but some of these softwares are really expensive. So you should consider that. The only one is this free one, this Open LCA. This means open really because this is freely available. But with the tool alone, you cannot work. You still have to buy a database because in Open LCA normally there are no datas um, included. So you still need to find the data. I don't want to go through the different models. The only thing beside the grid model, this Open LCA model is freely available and is relatively good. The Echo Invent database is very common in Europe, yeah, because it was developed in Switzerland. They have many data sets. It's not for free, and the good thing on the Echo Invent is that you find all the different impact categories, as Professor Singh showed us with his midterm and endpoint indicators. They are all in the Echo Invent. Yeah, so they really have covered all the impacts, whereas the grid model is relatively limited in the impact. So they are considering mainly inventory data about the primary energy consumption, the fossil energy use, the greenhouse gas emissions. They have air pollutants in there, the SO2, the NOx, the particles, and the water consumption. So they only have these five, where all of them, except greenhouse gas emissions, at least they're all happening on inventory level. Only for greenhouse gases, they do the assessment by taking the CO2 equivalent of the different gases and calculate the CO2 equivalent. Because they believe, that's the American belief, they say the inventory data we like more because they are really on a physical basis and they already help you to compare and judge on different systems. This is at least their philosophy or their strategy, to keep as long as possible close to the inventory data. That's why the grid model has at least a limited amount of impact categories, but I would say still a reasonable amount, and for a starting point, the best. If you really want to go further, you have to go to Echo Invent, I would say, because I think Echo Invent is at least the, the only database. They have really all these indicators, but as you open, for example, the sheet on human toxicity, and you get a long list of different assessment methods of human toxicity, this is a challenge still. Yeah? And so what is the take-home message from this? There are several LCA tools and databases are available. They calculate properly. Yeah, so if you handle them properly, yeah, so if you do the right thing in the program, it works. And the key questions for you is really what is needed. What do you need? What is your question? And secondly, also this transparency. Yeah? How transparent are these calculations? How easily do you find the key data, the basic data, the emission factors? And how easy is it to integrate new data in the model and to also get out the results for any further use? That's also relevant. I forgot to mention that, for example, for the EcoInvent database, where you have to pay for, you are not allowed to share the emission factors with somebody else. So if you publish a research paper and you took the grid electricity mix from Austria from the EcoInvent database, you're not allowed to put in the 200 grams per kilowatt hour taken from the database, because this is not allowed. Yeah, you can only show intermediate and final results, so things you calculated. And this is a big disadvantage in transparency. Yeah? Because if I review a paper and he tells me I use the Austrian electricity mix, okay, but I also want to see the gram per kilowatt hour he used, yeah? Because then I know if this is reasonable or not. If he tells me 2000 or 20, I say this is not wrong. So in terms of transparency, this key data, yeah, if you drive an electric vehicle and they only tell you I use the Austrian electricity mix, and it's 3 times better than the gasoline car, I don't believe this until I have seen exactly what electricity mix he has assumed and what is the CO2 value. Yeah. So this is at least also things you have to consider, and in the scientific community, at least it's necessary to put the key data also in, at least in an annex or wherever of your paper, because transparency, as scientists, transparency is always key. Yeah? And if that is not possible because of the copyright of this product, so this is sometimes also for us difficult if we use data from EcoInvent to not harsh the copyrights. Okay. The last example is at least focusing on one tool which has been developed in Europe, which is only dedicated for biofuels. Yeah? So it's this BioGrace tool. You can download this tool for free in the internet. It will give you a message on the very beginning that this tool is not reflecting the current regulation in Europe, because the tool was not updated for a few years while the regulation changed. But this does not harm the calculation in the tool itself. So this BioGrace tool is only dedicated for biofuels. And they have in the most relevant biofuels, and you can also use data that are already implemented there. And I think this is maybe the easiest way to jump into LCA of bioethanol, for example. And in this BioGrace tool, again you see the key processes starting with agricultural land. So in the tool you find one sheet about cultivation, about transport, the bioethanol plant, the distribution of the bioethanol, and the vehicle if relevant. I think this tool stops at the biofuel, so it ends after the bioethanol, giving you a value in megajoule, gram CO2 equivalent per megajoule. And at least I have just to guide you quickly through the system. And this is an example from bioethanol from sugar beet. And this is the summary table. We are telling you that the final result of producing ethanol with this data we use here, you end up with 40 grams CO2 per megajoule. And it also tells you here, is that allocation necessary for the process or not? So you also see on one glance the allocation factor. It's also nice, it also shows you the unallocated value. So you have a clue if you exclude somehow the byproduct, how much higher would be the emission if you put everything on the shoulder of the bioethanol. And it also gives you, shows you in which step you have the highest emission. And again, you see it's the cultivation and the processing which adds you up the most. And so this tool starts with this summary, and then you go step by step. The different cultivation step is the first one, and it's at least relatively the white cells here. They tell you first about the yield. What is the yield of the sugar beet, and what is the water content of the sugar beet? Yeah, when you harvest it, that's something you have to know. At least also how much diesel do you need for the machineries. If you don't have your own value, use this value. Yeah. So here are already default values in there. If you don't like that because you have your own calculation, talking to a farmer how much liter diesel he needs, then you can put in your value. If that is not the case, you can use the diesel consumption for all the machinery, yeah, for the seeding, for the harvesting, field preparation. And then here you have a long list of the agrochemicals, we call it, which are mainly the fertilizers. It's a nitrogen fertilizer. It's also a manure. You can also fertilize with manure. There's a calcium, kalium, phosphor, even pesticides. Yeah. There at least how many kilograms on pesticides, on fertilizer you put on the field. Yeah? And if you have your own value, if you don't need 120 kilogram nitrogen, you only need 110, you can override that. Here finally also the seeds, yeah, because making the seeds also, when you start sowing, you need seeds. Also, the making of the seeds is an emission, and also how many seeds you need per hectare. So we need a 6 kilogram of seeds. Yeah, the farmer knows that to plant 1 hectare on sugar beet, and finally also the N2O emissions. Yeah, so how much N2O is emitted? Here it's a 3 kilogram per hectare and year. The program itself, oh, I think I have not printed it out, but the program itself has also an extra sheet where you can compare different N2O emissions. Yeah, so at least also here it's a default value. If you don't have a better one, you just insert here. They used also the N2O emissions, for example, from the IPCC. Yeah, so they also are on the safe side. Or there is a separate sheet saying you can calculate your own N2O, where they have a modeling of this relatively complex uh, methanol, not methanol, N2O formation processes. Um, if you use wheat cultivation, it's the same sheet, but of course wheat you grow differently. You have a different yield, you have a different moisture content, different inputs, but the same is also available for wheat. And again, if you have your own data, you can always insert it, so you have a relatively good way. So these are the key data for cultivation, yeah, which is clear. The farmer needs diesel to run the engines. He has a yield, that's what he harvests, and he has to put things on the field that something is growing, which is fertilizer and plant protective agent to do that. And then the next step is you have to transport the sugar beet to the factory, and the transport is mainly a question of the kilometers, yeah, how many kilometers you transport it. There are different vehicles integrated there, a big one, a small one, and it also asking if it's running on diesel or any other fuel. But at least the transportation is relatively simple. But for transportation, the most tricky thing for transportation is you go to the field, take the sugar beet, and bring it to the bioethanol plant, and then you go back. But you, in most of the cases, you go empty back, yeah, because you don't bring something from the ethanol factory back to the field. For the sugar beet, sometimes they bring the earth, because when you harvest the sugar beets, they are cleaned in the sugar factory, and the earth is brought back. But normally, it's going back empty, yeah. And that's a question: if these 30 kilometers include both distances or only one? And at least you have to make sure that it's the full distance. Even the truck needs a little bit less energy if it's empty, that's for sure. That can be calculated in the kilometers, but normally it's the double distance for many products, not for all of them, but for many products. They go empty back, or they have a certain system, and in average it's they only run at 40% empty. But this is for transportation very important to really consider both directions, the empty and the full one. Otherwise, you're missing a certain fraction of the emission. So this has to be considered. And this is already the next one. This is the ethanol plant already. Yeah? So the ethanol plant also needs only a few inputs. Yeah. For example, the yield. So how much ethanol do you produce per input? So per megajoule or per ton of sugar beet going in the factory, how much ethanol do you produce? And how much sugar beet pulp, so this is the animal feed, do you produce? Yeah, so how much main product, how much byproduct, so this is included here. And then they ask you how much electricity do you need, and where is this electricity coming from? Yeah, and that has to be specified here, how much energy you need, electricity you need, and where is it coming from. And you also need much heat, so this part here is covering the heat. You also have to tell where you get the heat from for the distillation and all the facilities. So these are the key elements. All the other chemicals are not considered here, because in the final they need some additional chemicals, but their contribution to greenhouse gases is so small that in this calculation, it does not change the result at all. Yeah? So from that point of view, it's really a good starting point because it's relatively simple. You need electricity, you need heat, and you have to input the amounts of ethanol and animal feed you are creating. The same sheet for wheat, it at least looks the same. You input the yield, and you put in. If you have, in some cases, you have a CHP plant, a combined heat and power plant, yeah, where you use, for example, natural gas to make electricity and heat, which is a little bit more tricky compared to only use natural gas for heat and taking grid electricity. But this program also enables you to integrate a CHP plant, because if the ethanol factory is having a CHP plant, you are able to also insert this in this calculation tool. Yeah, and then at least we have the ethanol distribution, and again the distribution of the ethanol is at least a transportation process. Yeah? In that case, they say you're driving 150 kilometers. Sometimes there's a depot or a bunker where you collect first the ethanol and then pump it out. That's why they have a little bit of electricity of pumping in for storage and pumping out. And then finally, so it's a storage, and finally you go to the filling station saying, okay, the filling station also needs some electricity for the pumping, and then the LCA stops. So then you really have the value on greenhouse gas emissions per megajoule bioethanol at the consumer side, when you start filling in. So this is the system boundary of this system, and at least I would say this is if you're interested to start an LCA, I think this would be the easiest way to start doing it. And here you see again the differences, and all the data are in there. So it's fully autonomous, and you also find in the different sheets the values that are used. For example, the production of 1 ton of nitrogen fertilizer, it tells you how many tons of greenhouse gases you have, or it tells you about the diesel, how much greenhouse gases. So the key data are all in there. So at least it has a reasonable size, only focusing on biofuels, and it's a good starting point. And anyway, you can always change data if you like. Yeah, so it's really flexible on that. And I just have a screenshot. This is the database. It's an Excel table where you find all the necessary background data, the fertilizer and the diesel, the greenhouse gas emissions and the energy consumption and so on. That is all included here in a relatively transparent form. And finally, I show you the summary of bioethanol from wheat. Again, you have always a good summary, which is in LCA really necessary. You've seen with my fact sheets and so on, to really summarize the key things that are relevant to understand and interpret and communicate your results. If you can summarize them in a table, and that's very good. And you really see here the different contributions, and you see in that case the bioethanol is having 26 grams of greenhouse gas emissions per megajoule. Yeah, so this is at least one of my nearly last slides. I have 2 more slides, but at least only summarizing up. We've seen that picture on the very beginning. Sustainability is more than life cycle assessment. Yeah, so we were mainly talking about the environmental part, but of course we all know economy and society are really relevant. But to judge on them, on all these 3, we think it's at least state of the knowledge. You need an LCA. You always need to consider the whole life cycle. This is the methodology to really judge on the environmental effects. And we at Ioneum, we are not only judging on the environment. I have also colleagues that use the same system boundaries, the same unit processes, the same definition of functional units, but they count in economic terms. Yeah, so then it's a money LCA, so to say. It's an economic LCA, and also the social LCA. Yeah, to describe the society is even more complex than describing the environmental. aspect, but social life cycle assessment is also something coming up, and at my institute we're really doing, we have different experts in the different fields, but the system boundaries, yeah, and that's also the homework you have to do and present more tomorrow. The system boundaries are the same for the economics and the society also. Yeah, so at least it's always covering the whole, and at least some of these indicators you can already well quantify. Others are under development, but I'm sure in future more and more indicators will come up, especially also in the social area. I think that is also quite interesting, but still, then you even create more indicators and even makes the discussion more complex. But still, this is something we have to deal with because life is not so easy. There are so many different views, and the more scientific based information you have, it's a good starting point to discuss and talk to others and make reasonable decisions. For this one, I have made no take-home message. I was tired on the very end, so I made no take-home message. But thank you very much, and if you have any questions, let me know.
Hello. Thank you very much for the different databases tools which are useful for this biofuel related, sir. I have a couple of questions. Okay. Number one is, I'm curious that which tool or which database you have been using in your last 20 years, which you prefer. That is the first question.
One good thing is that I do LCA since nearly 30 years.
30, okay.
So we have many data gathered in-house.
Okay.
Because we have worked with electricity companies, and so we have a certain data set we use in many of our research projects. We just say Yoneum research internal data. Yeah, that is one thing, and then we mainly use in specific projects the eco invent. In most of the cases, when there are very specific chemicals we don't have, there are so many chemicals, then we take them. Or very seldom, if we really need more impact than greenhouse gases, primary energy and land use, human toxicity. I think we never calculated human toxicity, but if we need more, we take the eco invent. And third, from the GREED model, this American model, we always like to look on that because it's so transparent and so easy to find the data you're looking for. So one is in-house, but for you, I would really recommend to use the GREED data, because they give you on the key impact, greenhouse gases, energy, a very good starting point. Very good starting point. And this eco invent is very big, very expensive, and very sophisticated. So for advanced LCAs experts, it's good. But if you want a starting point, I would really say that the GREED model, or you can also from this biograce model extract some key data for fertilizer production and so on. I really recommend to use these. They're transparent and the orders of magnitudes are perfect there.
Okay. So when we use this biograce sheet, what kind of errors we may get? Like some common errors. Like, do we need to fill all the details? Otherwise, it don't run. Like how it suppose.
No.
So you may not have some data. Of course, we need to have everything if you want to do proper LCA analysis. But let's say some data set is missing. One of the box we don't have. Whether it will run the program and give you the results, or
when you download biograce, even the GREED, if you download it, it runs because all the data are in for the defined chains.
Okay.
So it works.
Okay.
If you delete one, it still works, but then it's missing some input. But when you download it, everything works perfect. You can calculate everything. So with the predefined cases, it works perfect. And if you make something wrong, you take the original version and start again. So it really works perfect. So it's really a step by step. You can start changing something, and then you start defining your own processes. So really you can learn step by step and compare it to the existing ones. So this is it's really fully functional and everything is in there to run it.
Okay, thank you.
Hello, sir. Sir, I'm about to ask that, like we have some standard values to put in the software for the LCA analysis, and you said that yesterday Volvo company released their CO2 analysis, and their values were much higher than what LCAU did. So, from where did that difference came in the LCA analysis?
That's a good question. Um, on one hand, Volvo also uses in certain parts eco-invent data. Yeah. And the difference mainly came from that we have underestimated the effort and the energy input you need to make a vehicle. Yeah, because a vehicle consists of so many parts. Yeah, and Volvo knows much more of making the different parts of a vehicle than we did. Yeah, or in literature you found, and we had so far. So this was at least the main difference. And secondly, one difference was um, in the battery making, because depending on who is making the battery, we took an average, global average value, which is an average from many battery producers. But Volvo has a specific supplier of the batteries. I don't know where it's located, and they really got data for their specific batteries from their supplier, and there might be a difference. And secondly, or thirdly, 1 ton of steel is 1 ton of steel. But there are so different types of steel and characteristics of steel, but also where you make the steel. And we, in our generic data set, said we use data as a global generic value, so a global average value. Yeah, but Volvo buys the steel at a certain supplier. Yeah, and they also got the value from this specific supplier. And steel making here in India is different from Austria and China or wherever. So at least they had more information, specific information related to the product. You never get as a scientist because they don't tell you where they buy the different things. So this was one reason they have more specific knowledge where the battery is coming from, where the steel is coming from, and how much energy they really need to build the parts of the vehicle and to assemble them. Yeah, and this were the main reason why we have underestimated the results. And this is at least part of the game because LCA is always improving. Yeah, this is an iterative process. If you publish a paper today, this is state of the art. If you do another year of research, you iterate and you come to a new result. And this is at least the nice thing on LCA. It progresses, and the more transparent the documentations are, which data they use, and to also identify where we have different data. Yeah, and not saying, I say the best data is the one you really put transparent in the table, more or less. Yeah, this is the best data. If people start to hide data, that yeah. So the best way is really to put your data on the table, yeah, and then discuss about the table, about the figure. Yeah. Okay.
And I think that's all for today. And tomorrow we will be having exercise. So come prepared with your PowerPoint presentation on the aspects which have been given to you. Make use of the slides I have shared with you, everything. And some of the software which he has discussed, some of them are open source software. So you can make use of those software also. So thank you, and we'll meet tomorrow.